Today we'll kind of focus on a different sort of the work that we've been doing. Not a lot of folks here within the community are using the Spot instance support, but there are I know 2 or 3 teams that have been using, and they have had great success with it. I know Lyft uses it. I know Freenome uses it, and I know not Tribe, sorry, Black Shark is using it. I don't know if others are using or not. I've never really spoken to them about it. So we'll talk about Spot instances, why you should consider Spot instances, uh, and then some problems in it, and that'll lead to the next topic, intra-task checkpointing, and then from there we'll talk about some cowbell that we are adding and why we are adding that, and some more stuff, some sneak peek. All right. I guess to this community, I don't need to explain that machine learning is expensive. Right? Once you really start building models at scale, you'll be like, oh, this is costing a lot. It's also very compute intensive. Unlike many other processes, it's compute intensive from the user side. Like, there's no easy way to build a model just by writing a query, and hence building a model needs a lot of compute resources. It's very compute intensive. It's also very experiment driven. That means it's ad hoc and constantly changing requirements. You want to update and change things constantly before even productionize. And for these 3 reasons, we actually build Flyte in the way it is. It allows you to quickly iterate. And we are working on some of the other cooler things that will further improve that iteration speed. But you have to remember that with every improvement in the iteration speed, you're probably going to make it more expensive because there are more resources being used. So how does Flyte do that? Flyte basically allows centralization of infrastructure. So let's assume you're a company of tens of data scientists where you now use some sort of compute infrastructure for yourself. And you want to start building models. There's one option. Every data scientist gets their own compute resources. That's great, right? Like, there is no queuing. Everybody has their own resources. It goes pretty fast. Problem is now, it's a general question. How often does every data scientist build a model? Are they doing it constantly? Do they need the resources constantly? And then do they also need one machine or hundreds of machines? Do they need GPUs or not? Don't need GPUs. So then the question that's happening is like, okay, if we start provisioning resources per data scientist, we actually end up with a scenario of like underutilized, lots of compute, which actually leads to a bunch of problems of specifically cost. And as we already said, it is costly. So how do we handle that? And that's what Flyte does. Flyte gives you one central plane to to centralize all your computations. It doesn't centralize the actual management of your models itself, but it centralizes the management of the infrastructure, which is actually pretty cool. Like, your MLOps teams or the platform teams can now own the infrastructure, while the user teams can simply use the API to execute their stuff. But then this has another problem, as more and more and more now, tens to hundreds of users start coming in, and lots of contention increases for resources. Now, one option is to elastically just horizontally scale and add as many machines as you can, even add more Kubernetes clusters. Flyte supports all of that. But if you add n number of machines, you basically are going to increase the cost. It'll not be as much as giving each person its own individual cluster, but it's still going to be higher than at some scale. It starts becoming very, very expensive. At Lyft, for example, it was one of the most expensive services we used to run. And so, how do we reduce the contention? To reduce contention, besides contention, there's another problem, right? Like, we may cause some unfairness within the system, that one user who's coming in and hogs up all of the available capacity, and the next user who comes in actually has experiences what we call as head of line blocking. So Flyte provides and uses things like resource quotas and resource pooling to prevent head of line blocking and improve fairness. And in the future, we'll also be adding things like preemption to improve further. But as I said, if you increase the cluster size in total, you'll keep on increasing the cost. Now, one idea is to over-provision resources by reserved instances. And if you're not doing this, we highly recommend this. What this means is provision your cluster with Flyte with like a max bound. You of course set the minimum to 0, but the maximum is, let's say, 1,000 machines in the cluster. And you probably want to set that 1,000 machines and buy 2 or 3 different SKUs and buy them and configure them in the cluster. We actually recommend buying one large machine as the SKU because it improves how the machines come up, though it might affect, depending on the amount of load that you have at an average, it might affect the utilization, the total utilization. So, you have to do a little bit of math over there. But then, if you buy reserved, you still cannot ever buy the complete peak capacity, and you should not. So then you spill over to on-demand. And if you spill over to on-demand, it's really, really expensive. The chart on the right actually shows you on-demand is 0% discount, assuming there is some discount, but let's assume the 0% discount. There's no commitment though. You can directly scale up and scale out. That's the promise of cloud computing, and it's amazing. But it's pretty expensive. When you use reserved, you actually get about 40 to 60% discount, depending on the organization that you're in, and you can save. But you have to give commitment of usage, and you can save a lot of money. The last option is to use this thing called spot machines, and spot machines give you about 50 to 90% discount depending on your bidding strategy. And what this actually does is it gives you benefits of beyond reserved almost, but without any commitment. But the other side of it is AWS gives you no commitment as well, or AWS, or even GCP called preemptible instances, and Azure also has an equivalent. So they give you no commitment. What that means is they will take away your instances at any point in time without much of a notice. But if its cost is an extreme concern, then spot instances become very, very lucrative. And we actually think for mature organizations, or where as you start scaling up and you're doing more experimentation, spot machines actually give the best value. But as I said, remember, things will go away. And how do you use spot? First of all, it's extremely simple. You can go to Flyte and turn interruptible for a task. Why is this an opt-in feature? There's an opt-in because, as I said, with spot machines, the machines may go away anytime. So your tasks may not inherently be okay with losing machines frequently. So it's better to opt in, and you can mark it as interruptible equals to true. Another option is you can actually make the entire workflow interruptible. That will make all the tasks within it run on interruptible hardware as long as it's possible. Okay, is this it? No, you have to do a couple of tweaks in the back. You have to actually go to FlytePropeller and update, either use a node selector or interruptible tolerations. So the way you do it is you'll create 2 pools, non-interruptible and interruptible nodes in the back end, and then have specific labels on those machines so that Flyte can target those the interruptible machines whenever the user predicts indicates that they are interested in using interruptible. So this is an example configuration. Either of those or together could be used. But interruptible gives you all of these benefits. It does, as I said, it comes at a cost. The machine will be taken away at any point in time. What this could be, I don't know if you know thrashing. This actually is a picture of thrashing. Thrashing means these are rice paddy, or I think wheat. I forget which one. And thrashing comes from this agricultural term where you actually take and you bang a bunch of these crops to extract the grain. And now imagine this person who's thrashing is actually AWS, and it's your task that's running. Invariably, you'll find that when you're about 90% complete, is when your task gets thrashed or moved out. Yeah, we could start again, and again you'll be 90% complete, and again, and this is a never-ending cycle potentially. So Flyte does give you one interesting solution in there, and it automatically does this for you. So if you have n retries, it will automatically retry n-1 times on spot or interruptible hardware, and then the last try, it would directly move it to a on-demand or reserved hardware. That way, it gives it the best chance of survival. But that still is expensive, right? Imagine you're training a model for 10 hours and it's 9 hours and it kills. And again, you do it and you have 5 retries. So you essentially end up spending 50 hours potentially. And it would have been much better to just put it on reserved instance in that case. So how do you solve that problem? That's one way. I mean, you can, of course, break it down into smaller and smaller chunks, and you should do that. And that's why Flyte is designed in the way it is. It is, workflows are a simple way of checkpointing. You can break it down into small tasks, and every task will be checkpointed independently. And these are logical checkpoints. But in terms of like things like model training, and as I said, in some cases, let's say you're replicating a database to another database. It's like a long running task. You can't really build a workflow per every single row in your database. That would be too many workflows, and it's not really scalable. A better solution would be that you basically bring up a task that runs for a long period of time, and it itself kind of checkpoints itself periodically, so that next time if it crashes or something, it can just begin itself from the previous successful checkpoint. And this is a pretty well-known architecture for checkpointing complex systems. Now it does need user involvement because you have to make your code resumable, and it does need a lot of infrastructure support to actually make those checkpoints durable, automatically pass them through, make sure that they don't corrupt each other, make sure that you can always resume from the previous checkpoint, like a lot of different things, right? So it is great. It would work, but it needs a bunch of infrastructure and user effort. So Flyte makes that extremely simple using intra-task checkpoints. We provide a very, very simple usable interface called checkpoint, where you have a bunch of different methods. Like you can actually checkpoint entire files or directories or paths. Or you can actually checkpoint just byte arrays. And in this example on the left, I'm showing how you can use it in your task. So let's say you have a checkpointer and you want to specifically, you have a range of iterations that you want to do, let's say 100, and you want to checkpoint every 10 iterations. So you would probably do a modulo algorithm and see like whenever your iteration hits a modulo 10, then you would write a checkpoint. And then every time you start up, you would try to read the previous checkpoint. And if the previous checkpoint exists, initialize it to the actual value in the previous checkpoint. In this case, you can automatically resume. There is some user work to be done, but you don't really have to think about how the task is getting retried, how the checkpoints are getting moved between them, how are they getting persisted, how they are getting durably written, how they're ensuring that there is no corruption on them, etc., etc. And that's it. If you write this, you will be able to checkpoint any specific long-running task. But how does this work in the back? So if for those who are aware of FlytePropeller, is the thing that actually runs your task in the backend. It today already creates data sandboxes for every single execution. And data sandboxes are the way to ensure that from a user point of view, it looks as if this is exactly once processing, but in reality, there is no exactly once processing in Flyte, right? There is just no way. When we run a task, it's possible that the network might partition and we might just lose visibility into the task. And so then at that point, we start another task. But in these cases, what FlytePropeller does is it allows you to create data sandboxes as well as checkpoint sandboxes. And then for checkpoints, it does something special. As it restarts another instance, it reuses the previous checkpoint and automatically passes it to the next. And FlytePropeller does all of this automatically. Okay, so as I said, checkpoints are available, but what's coming in? So currently, if you run checkpoint, it's only within one execution. Across executions, you cannot recover from a previous checkpoint, but that's something that we're working on. It's actually not that hard to build, and this actually fits in very nicely. So for example, if you're training a model and crash in between and the entire workflow crashes even after retries, but you're like, oh, this was just a system error, or I know if I recover, it will just work. So you can hit recover and it'll continue from the last checkpoint. Another thing, we want to actually make it even easier for users to checkpoint and make this more of a habit instead of like an afterthought. And so FlyteKit will have a set of plugins for model checkpoint wrappers. And most popular libraries like Keras and PyTorch Lightning, etc., have a checkpointing callback. And these higher level wrappers will essentially implement those APIs. We would love community contribution. I think there were a couple community members who actually said that they would be implementing this. I'm looking forward to working with you guys. Would love contributions here. Another thing is today in Flyte, all checkpoints are synchronous. That means when you write a checkpoint, you actually pay the penalty of durably storing the checkpoint. Eventually, we would like to make them asynchronous. Now, there are a bunch of problems over there because what if there's one checkpoint is being written and another checkpoint is to be committed? Now, it causes a bunch of queuing, and we wanted to avoid those problems at the moment. That's why there are synchronous checkpoints. All right, so that's checkpoints. Now, we'll talk about Flyte Decks, because we got to have more cowbell. I don't know if you guys know, this was a SNL thing some time ago, which actually talked about adding more cowbell to their music, and it just adds that extra pizzazz to the song. So, but on a serious note, machine learning is a very visual process. Oftentimes, when you're training a model or transforming a data set, you would want to visualize many aspects of it, because for large data sets, looking at the data set is not really useful. Visualizing gives you quick hints on maybe the data distribution or various aspects of it. So in this case, it's an example of visualizing a data set. And in this case, actually, I think this is some MNIST, maybe. It looks like MNIST. Yeah. But Flyte actually already gives you a lot of visualization. Visualization is one of the core reasons why I use Flyte. You basically try to visualize the inputs and outputs of every task, get the graph of the workflow itself visualized ahead of time. But from Flyte's point of view, a task is opaque. You can only see the logs. It doesn't know anything else that's happening inside it. What if we could have custom visualizations for a task? And that's what Flyte Decks is. We're still working on the name. Please, if you guys have suggestions of a better name, we would love it. We like Flyte Decks just from the point of view that this is on the deck of the flight. It's a pun intended. So, but we did hear from a couple folks that it should be called report. You wouldn't look at this feature unless you wouldn't know what you would want, what you were looking at, for example. So, or searching for. So yeah, anyways, name aside, but this is the programmatic way that you can enable custom visualizations within a task. On the right-hand side is an example. You can write a simple task, create a new, import a default deck, append to the deck, or create a new deck and simply append an HTML element to it. And these are all static visualizations. It could be Plotly graphs, which have some interactivity, but they're limited to everything that can be embedded into an HTML. And also along with this will be a set of renderers, as we call them. These renderers are essentially simple protocol that allow you to convert any data set into a renderable HTML file. And the reason to create the renderers really is to create a library of a bunch of renderers that, so the users, it minimizes the users' need to build renders themselves. And here's an example of a rendered output. So this is in a PR today. We're still working through, like, as we said, naming concerns and so on. But we will always automatically visualize inputs and outputs, but we will keep it secure. That means if you have a pandas data frame, it's not going to get visualized completely. If you want to visualize a pandas data frame, you can use the custom visualization and add that, add a frame renderer. In this case, you can see it's, somebody implemented a pandas profiling report on the right, and I think the Gojek team, and on the top is just a simple visualization of the pandas data frame as an HTML. In the future, we definitely wish to expand this to other visualization aspects of a task, like amount of peak resource usage, etc. So I think this will get exciting in the future. Please comment on the PR. The API is still in a little bit of a flux, but we want to stabilize this soon. Community support for building renders is extremely important. Right? I think this is something where the community can really contribute and drive up the library of renders that people have. Okay, the last segment, stuff that's coming soon, or next episode preview rather. What are we working on? So we are working on fast register. I think we've heard a lot from people. People like fast registers. They love it because they can easily write code and push their code without rebuilding a Docker container. But they don't love it as much because you now have to open up a connection to your backend blob store, which means potentially giving your users access to a backend blob store. But what if I said that your users could simply use Flyte authentication to automatically get access to transparently upload the fast registrable artifact, right? What would that make? That would make this configuration, this big configuration, which has the admin section, which is where to find Flyte, which is required, and a bunch of storage section, which is definitely not required, to go away. So that would result in this smaller configuration. And now you could just say FlyteCTL register files fast and not worry about how to connect to, whether it's Minio or S3 or GCS or blah, 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 how to connect to it and so on. And this is what we are working on. I'll keep it a secret as of now, however we are working on. Not really a secret. We are using signed URLs as a thing to actually upload. Next thing that we're working on is Flyte Remote. We have also learned a lot about how people have been using Flyte Remote. Thank you for staying with us through the beta period of Flyte Remote, but we think we are ready to graduate it to be out of beta. One of the things that we're doing is updating how you initialize Flyte Remote. We want it to be completely programmatic and extremely simple instead of fiddling around with files. So in this example, you can see Flyte Remote can just be initialized for an endpoint. And you can now, the example also shows, fetching a task from remote, building a workflow from that fetch task, and also intermingling with a task that's local. Caution here that these tasks are non-container tasks in the case when they're defined locally. So it's a query. And then you can just simply execute the workflow, pass the input, and it should just execute. You can also, of course, retrieve prior executions and fetch the outputs. So all of this can be done through Jupyter environment, and this is Flyte Remote will get more and more friendlier for Jupyter usage. Another complaint, and specifically through the hackathon that we've been doing, and all the new users, today Flyte Sandbox is essentially this I don't want to call it house of cards, but a crazy assemblage of Kubernetes and Docker in Docker and multiple different containers, and magically working to give you this local Flyte running in one box experience. And we've been extremely grateful for working with Jeev and other folks to get this thing out of the block. And it's gotten us this far. But we've learned that all of our container images are actually hosted in North America. So when people are in other parts of the world, when they start pulling, it takes time. Every time you stop the sandbox and you restart it, it again pulls all the images. And there's no easy way to pause and resume a sandbox. So listening to all of this, we are actually working on something even with a single-minded focus that we want to get your sandbox up in less than 30 seconds for the first time, and then continue to keep that restart time low to like maybe even less than 10 seconds whenever possible. So for that, we've minimized all the components and we're trying to build one single binary for all of Flyte. And this single binary is what you deploy. It's part of your container image already. We still need Minio, so there probably won't be a way out of that, but I think Minio is probably pretty redundant across the world in their hosted solutions. And yeah, and it should look exactly the same, but just be way more snappy and get started. So this is something that we're working on. This has another benefit, by the way. If you realize today, if you are along with the no pulling container pause resume, all of that stuff, there is no Postgres in the default local installation that way SQLite, so that it can really start up very quickly. But what if you could just take that single binary and deploy it to EC2 instance with a static IP, point it to an Aurora database, an EKS, and an S3, you would have a production grade Flyte cluster without really fiddling with ingresses and load balancers and et cetera. And we've seen a lot of people really struggle with that stuff. And so that's one of the single-minded motives that we started this project with, to really aid the community to get started with Flyte extremely quickly, and also to scale it to an EKS production cluster in relatively short period of time. Now, this is not really a full production grade HA kind of a deployment. For that, you will need more than one instance. But the moment you add more than one instance, and it's possible the single binary can be just run itself 3 times and it should work. But for that, then you need a load balancer. But besides that, this just super simplifies how you get started with Flyte. And finally, we are working on something called a Flyte script mode. So you take the example on the right-hand side. You write this workflow, and most people are like, okay, now I have to do package, and I have to do register, and I have to build a Docker image. There's multiple steps that you have to do. And actually, Merantix and all of these other people have kind of showed us that there are other ways of doing it. But specifically, the current flow is a little tiresome. So we started with like, what's the best way to get started for specific, simple Python workflows? And so we are working on a thing called as PyFlyte run, and you can just give it the name of the file with the name of the workflow to run, and boom, it's just that's running. You can pass, it will always start with a default FlyteKit image, and it will use fast register to instantaneously run things. Another thing is like if you have a large enough project like Flyte Stacks, you can make PyFlyte run fully relocatable, go to any folder, anywhere, run PyFlyte run for that file, and boom, it just runs. So that's the goal we are going with. It will come through a couple iterations, but we are thinking that the first version will be out pretty soon. All right, that's it. A huge, sorry, I talked a lot, but I want to open up for Q&A. And let me stop sharing. Hopefully that was useful. Any comments, questions, concern? I see Soren smiling, so.
Yeah, just wanna add something about the checkpointing API. So one more of a comment. So one other thing where this is really usable, or what I found very helpful, is that you can also write out your TensorBoard metrics during checkpointing, because usually you do that while saving and evaluating anyways, right? And then you write it to a checkpoint, and then you can just use these checkpoints during training to fire up a TensorBoard instance and connect to the bucket and see your training progress. So this is kind of useful also.
Yeah, we never really thought about TensorBoard when we were doing this, but yeah, you could. Today we don't host TensorBoard, but I think in Flyte deployment probably someone could help us, like, you know, host that thing elsewhere, and it will be very useful to folks. Fantastic. Yeah. Also, Soren, you are contributing an example using checkpoints, right?
Yeah. This is it's not Keras, but the Hugging Face trainer API. So it's basically this is another wrapper around PyTorch, but yeah, of course, it's basically the same, right? They have a callback, and so perhaps we could add a plugin or something like that.
Yeah, I was actually thinking if there is a loose coupled way of doing these plugins where you don't have to install Hugging Face and PyTorch and TensorFlow, then you could put all of them in like this one plugin folder. We could probably just, like, you know, do based on import and try catch in there in that plugin. But if you are, I think adding them will really help many other users, because not everybody is as savvy as you. So
yeah. So
Jeev
actually,
has a question. Sorry. Okay. No, go ahead.
So one question about the checkpoints, because when I was using the trainer API, there's actually a feature that you can like only keep the latest or the best checkpoint, but I was storing the whole output folder basically where all the checkpoints are in, because the trainer API basically manages that. But now, because it's written to the bucket, in the bucket, of course, it's not deleted, right? And so if you have a lot of large model checkpoints, it's gonna be a lot of storage. So I wonder if this is something maybe we could add something to clean up checkpoints, or don't know.
Yeah, I think we should talk about like just GC in general, like of the data, because a lot of data is generated. And I'll give you what we did. We just had bucket lifecycle policies essentially and which we kept it at like 90 days or maybe 180 days, and then we just periodically just deleted all the data. And then the understanding was that the Flyte workflows then only, or the execution history just is a reference history. It's not really the data. So if you want to redo the data, you have to rerun it. But this has a couple of problems, and we actually should work on adding just GC in general into Flyte, I think. Hopefully this year at some point we'll start working on that, and we'd love community collaboration on the GC part.
Cool. Yeah, thanks.
Also for your, like, I think if you use the directory API, Soren, I guess that's what you use, it does copy everything, but you can use a file API. So then it won't copy everything. It only copy the one file.
Yeah, I guess I was too lazy. I guess I think it should be possible to just actually extract the latest or the best checkpoint from the API and just write that out. Probably that's the way to go, I guess.
Yeah, I don't know. I think so. That's why we have the read and write, which is byte arrays, so you can or a file handle, so you can just upload that. Cool. Another one, Jeev has a question. Love the idea of Flyte scripts, and it might play nicely with notebooks as well. Are you thinking of using pickling? fantastic. So single script mode as is what it is. It's a script. It is not a notebook. It's not IPY-NB files. It is .py files. If you use JupyText, by the way, pip install JupyText, then you can open Python files, .py files in Jupyter. And you can basically use Flyte with Jupyter and have a terminal. But on that front, we are working on something that will use pickling. And that's where Flyte Remote comes in. So Flyte Remote is the Jupyter land in our head. It's like, this interactive world where you can like do things. And of course, it comes with its own set of problems. And so we will, of course, advise people that dip only as much as you are comfortable with. Like, if you know how to swim, dive. If you don't know how to swim, stay in the shallow part. Basically, the way we are thinking is like in Flyte Remote, when you register, you can pass a task reference, and that'll automatically pickle and use fast register under the hood to send the pickle artifact and rehydrate the pickle artifact at runtime. And that's completely doable today. Yi says that it's doable within no time. I doubt it. So, but soon, we're hoping to get something out in April. And this is our the experience is what we care about for the next 2.5 months. We really want to even hone in further on the experience.